Section 6.2, Factoring Trinomials. So in this section, we will factor, well, we'll mostly factor at least mostly, quadratic polynomials, quadratic trinomials over the set of rationals. In fact, we'll be doing this over the set of integers. So we're going to be looking at quadratic trinomials, expressions of the form ax squared plus bx plus c for some constants a, b, and c. So let's look at some cases. So the first case that we'll be looking at is the case that the coefficient in front of the quadratic term is 1. So this is the monic case. Case 2. So this is the non-monic case. So we'll split this into really two different cases here. The first case will be when, well, the coefficient in front of x squared, the quadratic term, is not 1, and so it's not a monic polynomial. But it turns out that we can actually factor out a greatest common factor. And so where the greatest common factor of these coefficients is a, which is not 1. Maybe I should just say with the greatest common factor. And so you can factor out that term in front of the x squared. And so that it really does look like it's some constant times a monic polynomial, in which case you can do the above cases. So this is the case 2i. Now let's do the second one, is where, well, the coefficient in front of the square is not 1, and the greatest common factor is not a. So you can't factor out the a. So somehow it's, we're going to actually have to deal with it. Okay, so let's do factoring. And really, we're going to be factoring over the integers. I'll just say that we're factoring. It's understood that we're factoring over the rationals, factoring over the integers. So basically, what we mean is that we have somehow written ax squared plus bx plus c as the product of a, b, c, d, e, f, g. Okay, so I've written it as a product of two linear terms. So I've written this quadratic as a product of two linear terms where a, b, c, d, e, f, g are all integers. And so then that means we're factoring over the integers. If instead they were all rational numbers, which then we would say that we're factoring over the rationals. So factoring over rationals. So in that case, A, B, C, D, E, F, G are all rationals. And if I say I'm factoring over the reals, then that means that A, B, C, D, E, F, G, these are all real numbers. In general, when I say I'm factoring, I mean I'm factoring over the reals, over the over the rationals, which in this case is the same as factoring over the integers. Because all the coefficients are integers, so it doesn't matter saying rational or uh, integer. Let me do, first I guess I'll start doing examples for case one. So let's look at page 271. And so in exercises 1 through, I'm sorry, in exercises 13 through 48, factor the trinomial. So let's do that. So let's start with problem number, let's say 14. X squared plus 8x plus 7. So this is going to equal, so this is x squared, so I'll bring down the x. So first, this is a minus sign, so I'll bring down the plus. I'm sorry, this is a plus sign, so I'll bring down the plus. And now I'll multiply positive times positive becomes positive, so that's a plus sign. So this means here that both signs are the same. Well, in this case, they're both, since there's a plus sign here, they're both positive. So both signs will be positive. Okay. Next, I want to find two whole numbers whose product is 7 and whose, well, let's see, since there's a plus there, sum is, well, let's look over here what the sum is, 8. Okay, and so I want to determine two whole numbers whose product is 7 and whose sum is 8. So 7 and 1. And that is your answer. So another way of thinking about it, I can bring down the plus times plus is plus. I want two whole numbers whose product is 7 and whose sum is 8, so 7 and 1. I then put the larger factor, oops, and put larger absolute value factor. And so I'll put the larger factor first. Let me do problem number 16. A squared minus 7a plus 12. Okay, so this will equal, again, I can factor this. These are a's. So drop down the minus times plus is minus. And so drop down the minus times plus gives you a minus. Okay, good. So again, this says that both factors or both signs are the same. They're both minus because there's a minus here. And so I want to find two whole numbers whose product is 2, because there's a 2 here, and whose, well, there's a plus here, sum is, well, let's see what the sum is, 7. Okay? And so, let's do that. I want to find, oops, that's a 12, by the way. I want to find two numbers whose product is 12 and whose sum is 7. Okay, so I can do that. So 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. And I'll place, oops, and put the factor with larger absolute value. in the very first spot. So the 4. Okay. Let me do problem number 18. Y squared plus y minus 56. Okay, so actually let me review this above that I just did. So I have a squared, so I'll put a's here. I have a minus, drop down the minus, times plus is minus. I want to find two whole numbers whose product is 12 and whose sum is 7. And put the larger factor, 4, first. Okay. So I have here y squared, so I'll put y, drop down the plus, times minus is minus. So this says here, the signs differ. Okay, good. This says I want to find two whole numbers whose, in this case, difference is 56. Oh, whose product is 56. That was a minus sign. I said it wrong. Whose product so I want to find two numbers whose product is 56 and whose difference is, in this case, 1. In place and put the factor with larger absolute value in this place. Okay, so I want to find two numbers whose product is 56, 8 and 7, and whose difference is 1. So 8, 7. So again, drop down the plus times minus is minus. I want to find two whole numbers whose product is 56 and whose difference is 1. So 8, 7. Let me do problem number 20. X squared minus, I guess I should have said, so I drop down the plus times minus becomes minus. X squared minus 8x minus 65. And so that's going to equal x. I drop down the minus, times minus is plus. And so this says that the signs differ. Signs differ. And so I want to find two numbers whose product is 65 and whose difference is 8, and put the factor with larger absolute value here. Okay, so I drop down the minus times minus is plus. I want to find two whole numbers whose product is 65 and whose difference is 8. So 13 and 5. Okay, so let me summarize what I've done here. So there's a lot of stuff I've written. So let's just do a summary. Okay, so suppose I had x squared plus bx plus c. And so I'm not going to put the a's and the x's and the a's, the x squares, the b, the x, and the c. I'll just say, well, if they're positive, such as in this case, this very first case here, I have a x squared plus 8x plus 7. Okay. And I'm assuming, of course, there's a 1 in front of the x squared, in which case they're both plus, and the larger factor, the factor with the larger absolute value, will be placed first. If there's a minus plus, drop down the minus times plus is minus. If there's a plus and a minus, drop down the plus times minus is minus. Minus minus, drop down the minus times minus is plus. Okay, so that's a summary of what we did above. So let me do problem number 24. X squared plus 21x plus 108. So this is x, x. Drop on the plus times plus is plus. I want two whole numbers whose product is 108 and whose sum is 21, 12, and 9. And I'll put the larger factor 12 first. Let me do problem number 28. X squared minus 11x minus 42. And so, again, this is a monic polynomial. So I'll put down the x, bring down the minus times minus is plus. I want two whole numbers whose product is 42 and whose difference is 11, 14 and 13, and I put the larger factor first. Let me do problem number 32. X squared minus 6x minus 135. And so let me drop down the minus times minus is plus. I want to find two whole numbers whose product is 135 and whose difference is 6, 15, and 9. Let me do problem 36. Y squared plus y plus, minus 132 And so this is again a monic polynomial. And so let me just put y's here. Drop down the plus times minus is minus. I want to find two whole numbers whose product is 132 and whose difference is 1, 12, and 11. And again, put the larger factor 12 first. Let me do problem number 40. Z squared plus 7z minus 144. Again, uh, these are all monic polynomials, so factoring these is quite nice. Drop down the plus times minus is minus. I want to find two whole numbers whose product is 144 and whose difference is 7, 16, 9. And put the larger factor 16 first. Let me do problem number 44. Y squared plus y minus 72. Again, this is a monic polynomial. Drop down the plus times minus is minus. I want to find two whole numbers whose product is 72 and whose difference is 1, 9, 8. Put the larger factor 9 first. Let me do problem number 48. (20) plus 12x plus x squared. Actually, I can write this in descending order and make it a little easier to do. So x squared plus 12x plus 20. So it's quadratic, a monic quadratic. Drop down the plus times plus is plus. I want to find two whole numbers whose product is 20 and whose sum is 12. 10, 2, and put the first number, the larger number first. Okay, so now let's start to look at case 2i. Okay, so let me do problem number 50. 3x 3b squared plus 15b plus 18. Okay, so in exercises 49 through 96, factor the trinomial completely over the integers. Okay, so let me do that. And so if I look here, I have a 3 in common everywhere. So 3b squared divided by 3 is b squared. 15b divided by 3 is 5b. 18 divided by 3 is 6. So the first step is to always check if it's possible to factor out a greatest common factor, just like what we did in the previous section, section 6.1. So if there is a common factor, factor out your greatest common factor. And so I've done that. And now I can factor what's in the parentheses. So remember to bring down the thing that you factored out, the 3. And so I have here b squared plus 5b plus 6. Well, that is, again, a monic quadratic. So I can use the exact same techniques that I've been doing, above. And so I have here b squared. So I have b's. Drop down the plus times plus is plus. I want to find two whole numbers whose product is 6 and whose sum is 5, 3, and 2, and write the larger factor 3 first. Let me do problem number 52. X y squared plus 7 xy minus 8x. So first I notice that there's an x in common. So let me factor out my x. So I have x, y squared plus 7y minus 8. Well, now that I've done that, what's in the parentheses is a monic polynomial, so I can factor using the above techniques. Drop down the plus times minus is minus. I want to find two whole numbers whose product is 8 and whose difference is 7. 8 and 1. Put the larger factor 8 first. Let me do problem number 56. 5y cubed minus 50y squared minus 120y. Okay, so the first thing that I notice is that, again, there's a factor, and so in common. So let's factor out the greatest common factor, 5y. What remains is 5y cubed divided by 5y is y squared. Negative 50y squared divided by 5y, 10y. Negative 120y divided by 5y, negative 24. And so again, this is a monic polynomial, so I can factor it. Drop down the minus times minus is plus. I want to find two whole numbers whose product is 24 and whose difference is 10, 12, 2, and put the larger factor 12 first. You're done? Okay, so let's look at case 2. So in this case, we're going to try to factor, but it's not a monic polynomial, and unfortunately, no matter what you do, it's still going to remain non-monic. So you have 2x squared plus 9x plus 10. There's no common factor, so you can't simplify this by factoring out a greatest common factor. And so none of the technique that I've given you above work. So that means that all these rules that I've given you for factoring monic quadratics will no longer be applicable. So you're going to have to invoke some additional sort of rules. And so let me do so I actually maybe what I'll do is I'll give you a reason. So note the following. And this will be the reason that all of these techniques will work. And so ax squared plus bx plus c, I can write this as, 1 over a times, or actually let me write it as a over a times ax squared plus bx plus c. So I've not really written it any differently. And so that's the same as saying, 1 over a times a, because the a's cancel. And so let me multiply the a inside the parentheses. And so this becomes 1 over a squared x squared plus abx plus ac. And so this is 1 over a times, let me group the a's and the x's together. So this is ax quantity squared. So let me rewrite the a and the x next to each other. So that's bax plus ac. And so this, in parentheses, is now a monic polynomial. So note, this is a monic polynomial, monic quadratic, in the variable ax with the same linear term, with the linear coefficient of b. Just like, so we started out with a linear coefficient of b. We still have a linear coefficient b, but now the term in front of the quadratic term is 1, so it's monic. But the constant term is AC. And with constant term AC. So all of these techniques will sort of work on this idea. And so first one that I guess I'll talk about is the so-called AC method. So let's do AC method. And so in the AC method, we'll be factoring by grouping. Okay, so the first thing that you should do is you should multiply AC. Okay, so let's look at this first term here. So I have here 2x squared plus 9x plus 10. And so the A in this case is 2, B is 9, and C is 10. And so 2 times 10 is 20. Okay, next, find the factors of AC so that the sum, if this term is a sum, then it'll be the sum. And if this term here is the subtraction, there'll be the difference. So that the sum or difference, depending on if that last term here is a plus or minus, is the middle linear term, b. And so, in this particular case, i.e., find the factors of AC. Well, AC in this case is 20. So that let's see. In this case, this is a plus sign. So it's a plus. And so that the sum is, well, the linear term in this case is 9. So the sum is 9. So I want to find two whole numbers whose product is 20 and whose sum is 9. So 4 and 5. And that's because, well, 4 times 5 is 20. And 4 plus 5 is 9. So good. So I have that their product is 20 and the sum is 9. Okay, good. So step 3, I want to write B as the sum or difference of these factors. and then factor this the rewritten quadratic by grouping first two terms and last two terms. Okay, so let's do that. So our original equation, 2x squared plus 9x plus 10. So let's write that down. 2x squared plus 9x plus 10. And so it says to write this as, well, follows. I'll write 9 as 4 plus 5. Okay? And so I've rewritten this as this middle term, 9, is 4 plus 5. And so I get 2x squared plus 4x plus 5x plus 10. Let's factor this by grouping. And so I'm going to group the first two terms and the last two terms. And so if I look here, there is a 2x in common. So let me factor out my 2x. What remains is x plus 2. There's a 5 in common. So let me factor out a 5. What remains is x plus 2. Therefore, what's in common is x plus 2. After I factor out the x plus 2, what remains is 2x plus 5. And that is your answer. Okay? And so that's the so-called AC method. So let's do the British method. Which again, and so notice the AC method is really just saying, well, you factor AC, okay? And because basically everything works because you can bring this to the back. Okay, so now the British method is just rewriting it using the above. And so let me factor this as if it were a monic polynomial in 2x. But since I've written 2 twice, I have to divide by 2. So that is that step here. So that's the fact that I've rewritten it this way. And so drop down the plus. Times plus is plus. Again, 2 times 10 is 20. So I want to find two whole numbers whose product is 20 and whose sum, because that's a plus sign, is 9. So 4 and 5. Okay, and so let's do that. Well, notice that I can't divide the 5 by 2, but I can divide each of these by 2. And so I get 2x plus 5. 2x divided by 2 is x. 4 divided by 2 is 2. And so I get the same answer that I get above. So that's the British method. Let me do the pullback method. Which again is just a different way of saying the British method. That's a different way of saying that fact that we can rewrite a non-monic polynomial as a monic polynomial in a of the new variable ax, as long as I divide back by the a. And so let me look at 2x squared plus 9x plus 10. And so what I'm going to do here is I'm going to create a new equation, a new expression. This auxiliary expression. So what I'm going to do here is I'm going to actually pull back this. And so I'm going to bring the 2 to the back. And so this 2 will move to the back. And so when I do that, I'll multiply. So this notation means when this little arrow is here, it means multiply this number, 2 times 10. Whereas this arrow here means divide that 2 by 2. And so the auxiliary equation is just x squared plus 9x plus 20, found by just bringing this 2 to the back. And so now let's factor. So notice in this particular case, this is just a monic polynomial, so I can factor it not like normal. And so x, using the above techniques, bring down the plus times plus is plus. I want to find two whole numbers whose product is 20 and the sum is 9, 5, 4, and write the larger factor first. And so I would be done, except now I've got to, if I put the 2 in the back of the equation, I've got to bring it back. I've got to pull it back in front. So now notice that I can divide 4 by 2. And so I can't divide, so I'm going to try to somehow divide these by factors of 2. Well, the only one I can divide by is the 4. So if I do that, I'm going to pull this back. And so I get, well, 2 times x is 2x. I'm not multiplying anything times the 5, neither by the x. 4 divided by 2 is 2. And that is your answer. Again, it's the same answer. Okay, good. We also have the x method, which is really just sort of a notational sort of way to do this. So I'll just draw a little cross here. And so it's really, well, what's going to be called the guessing method. You sort of guess a correct answer. So I have 2x squared, so I want to find two numbers whose product is 2x squared, 2x and x. I want to find two numbers whose product is 10, well, plus 5 and plus 2. Notice that they both have to be positive because of this term. And now let's do the cross. 2x times positive 2 is 4x. X times 5 is 5x. 4x plus 5x is 9x, so good. So therefore my answer is found by just combining these. And so I get 2x plus 5, x plus 2. So 2x plus 5, x plus 2. And, well, that's the same answer that we got above. Or your trial and error, your guessing method. Two x squared plus 9x plus 10. And so you just sort of guess the correct answer and then check it. So I'll put a 2x here and an x. And these are pluses, so I'll put pluses. I want to find two numbers whose product is 10. So let's say 5 and 2. And then check if this is the correct answer. 2x squared plus 4x plus 5x is 9x plus 10. So you're done. So you should check to see if your answer is correct. And so when using the guessing method, always check to see that you actually get the correct answer. So this is equal to 2x squared plus 4x plus 5x plus 10, which is 2x squared plus 9x plus 10. So it works. It's basically the way that, this is, if you look, this is how we factored by grouping. So that was back in the AC method. We sort of did it that way, but going in the other direction. Okay, so let's do some examples. Say problem number 60. So you can use any method you want. I guess I'll just do these using the guessing method. But you should practice on your own using, I would say, each method, and so that until you get faster and faster. And so you should actually know every method. I want to find two whole numbers whose product is 6, so 2x, 3x, and difference will be 7. So I want two numbers whose product is 3, so 3 and 1. And now let's check. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. 3 times 3x is 9x. Minus 2x is 7x. Good, that works. 3 times negative 1 is negative 3. Okay. Let me do problem number 68. (14x squared plus 19x minus 3). So I want to find two quantities that multiply to 14x squared. So let's say 2x, 7x. Two numbers who multiply out to negative 3, so plus 3 and minus 1, and then check the cross terms. And so 14x squared minus 2x plus 21x is 19x minus 3. So this works. Let me do problem number 72. 12x squared minus 23x plus 10. And so I want to find two quantities that multiply out to 12x squared. Let's say 4x, 3x. Two quantities that multiply out to 10. Let's say negative 5 and negative 2. And now let's check that this is correct. So I get 12x squared minus 8x minus 15x is minus 23x plus 10. So that works. Let me do problem number 76. 2x squared plus x minus 45. And so I want to find two quantities that multiply out to 2x squared. Well, there's not a lot of them. And so 2x and x. I want to find two numbers that multiply out to negative 45, so negative 9 and plus 5. And now let's check the cross terms. 2x squared plus 10x minus 9x is plus x minus 45. So that works. Problem number 80. Two x squared minus 17x minus 30. So let's factor this. Well, 2x times x um, plus 3 times negative 10. And so 2x squared minus 20x plus 3x is minus 17x minus 30. So that works. Let's look at problem number 88. 13x squared minus 5x minus 8. And so let's factor this. So this factors into 13x, x plus 8 minus 1. 13x squared minus 13x plus 8x is minus 5x minus 8. So it works. Let me do problem 92. 5x squared plus x minus 4. And you should be sure that as you do these, your speed at factoring increases, because in the next chapter, chapter 7, you will have to do a lot of factoring for every problem. So be sure that your factoring speed is quite quick. So 5x squared gives you 5xx. Negative 4 gives you negative 4 times 1. And let's check. 5x squared plus 5x minus 4x is plus x minus 4. And you have factored this completely over the integers. Let me do problem 94. 24 plus 2r minus r squared. And so let's factor this. And so two numbers whose product is 24, 6 and 4. Two quantities whose product is negative r squared, so negative r and plus r. And let's check. 24 plus 6r minus 4r is plus 2r minus r squared. You could have also done this as follows. So this is actually, this is case 2-1 if you write it properly. So you could write 24 plus 2r minus r squared as, well, let's write this in descending order, as negative r squared plus 2r plus 24. Factor out the negative, just like what you did in section 6.1. So negative r squared minus 2r minus 24. But then in that case, this is a monic quadratic. So bring down the minus, times minus is plus. You want two whole numbers whose product is 24 and whose difference is 2. 6 and 4, and you put the larger factor first. Note that these are the same if you would just multiply the negative inside. That becomes negative r, minus become a plus 6. And then you still have the 4 plus r. Let me do problem 96. So you get negative x squared plus 16x plus 17. So that's a negative x plus 17 plus 1. Negative x squared minus x plus 17x is plus 16x plus 17. Or negative x squared plus 16x plus 17 is a negative x squared minus 16x minus 17. And so what's in the parentheses is a monic quadratic. Bring down the minus, times minus is plus. You want two whole numbers whose product is 17 and whose difference is 16. So 17 and 1. And so you get the same thing. Okay. So that really finishes off section 6.2. So let me stop this. Oops.